Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2023 Combined Science Physics Paper 2 Higher Tier. Question number 7, which is on forces. A car contains a device called a black box. The black box records the velocity and acceleration of the car. The car was traveling at a constant velocity. The driver then reacted to a hazard. Figure 11 shows the velocity time graph for the car. Here, it's traveling at constant velocity here. It's a flat line and then it's decelerating here. Determine the deceleration of the car. So deceleration or acceleration is change in velocity v minus u divided by the time. Final velocity is 0. Initial velocity, there's 5 boxes between 0 and 5. So each of these boxes 1 meters per second. So this would be 26 divided by the time is 2 and 5.25. So 5.25 minus 2, that gives me minus 26 divided by 3.25. That gives me an acceleration of 8. And the unit for acceleration is meters per second squared. Remember, this is, let me change the color. So this is meters per second, and that's second as well. So meters per second divided by second is meters per second squared. (7.2) The driver of the car has a reaction time of 0.75 seconds. So reaction time is 0.75 seconds. Determine the stopping distance of the car. Use the physics equation sheet. Use figure 11 as well. So you have to use the equation sheet and figure 11. Now, you're trying to determine the stopping distance. Remember, stopping distance equals, let me rephrase that, equals thinking distance plus the braking distance. So you'll have to work out what the thinking distance is and the braking distance. So the thinking distance can be determined from the reaction time and the speed. So speed equals the distance divided by the time. So S equals Vt. So the thinking distance would be, the initial velocity is 26. So 26 times 0.75 is the thinking distance, which is 19.5 meters. To that, I need to add the braking distance. Now, the braking distance comes from the graph. How do we find the braking distance from the graph? The braking distance from the graph would be the area under the graph. So from there to there. So this area under the graph. So because it's a triangle, the area of a triangle is half times the length times the height. So The height is 26 and the width is 3.25. So 26 times 3.25, because it's a triangle, I'm going to divide that by 2. That gives me 42.25 meters. So stopping distance equals 19.5 plus 42.25. That gives me 61.75 meters. 61.75 meters. If the black box records large decelerations, it identifies that the driving may be dangerous. Explain why large decelerations may be dangerous. Now, large decelerations can cause the brakes to overheat and can cause the brakes to either fail or to stop it working completely, or you could lose grip on the road. So any of those answers will be fine for 2 marks. Because you're trying to explain, you have to say what actually happens, so not give 2 different reasons. The brakes can overheat, that's 1 mark, so the brakes will not work properly. Or you could say can lead to loss of control, that's your first mark, because the tires can lose traction or grip, that's your second mark. Or you could say the greater the deceleration, the greater the force, and larger forces can cause injury. But the best is actually just to simply say the brakes can overheat, so it will not work properly. That brings us to the end of the video and the end of question number 7 as well. Thanks for watching. Always click on the subscribe and like button, and I will link another video for another test paper as well.